Welcome to Study Loop.
41.30, we're told some information about a metal, and we want to find the number of occupied states in a specific energy range that's centered around a particular energy. So to give us some idea of where we're going, we'll call script n here the number of occupied states. This is equal to the number density of occupied states at the particular energy in question times the volume in question, because this is counting the total number, times the width of the energy range, and to break this down further into things where we can actually, we know what the equations are, the number of occupied states is, or the number density of occupied states is equal to the density of states times the occupation probability. And then V delta E stays the same. So we want to find the occupation probability and the density of states. And we'll go with the occupation probability first. So we know that this is 1 over e to the e minus ef over kt plus 1 . Now the Fermi energy is 0.121 h squared over the electron mass times the number density to the 2/3. And since we're doing this problem in joules for some reason, I mean, it's good to be able to work with, any sort of reasonable units. This is 3.855 times 10 to the negative 19th joules. And we are warned in the statement of the problem to avoid round-off problems in the exponential. So that's why we have this out to 4 digits. So now that we know our E sub f, E minus E sub f, is 1.45 times 10 to the negative 20th joules and if we divide this by kt, we get 5.2536 is the thing we're going to plug into our exponential. So the occupation probability here is going to be 5.2 times 10 to the negative 3rd Now the density of states is 8 times the square root of 2 pi m to the 3 halves over Planck's constant cubed times the square root of the energy. And so we know all of these things. And this gives us 6.717 times 10 to the 46th per cubic meter joule. So now the density of occupied states, like we said, is N times P. So this is 3.49 times 10 to the 44th per cubic meter per joule. And going back to where we started, now that we know all that we need to know, this is the number density of occupied states times the volume times the energy range. And so we have 6.7 times 10 to the 19th states occupied in this situation.